Okay, so what do you notice here about the difference in our ordered pairs when we subtracted versus added to our input?
One set keeps going down for the output, and the other set keeps going up for the output.
One goes up for the output, the other decreases, right? Both of these functions describe what we call an additive relationship. And an additive relationship just means the increase is the same every time, okay? Look at these outputs. They're increasing by, what are these outputs increasing by? 1. Do y'all see that?
Yes.
3, then 4, then 5, then 6. See how the outputs are increasing by 1? In our first set, the outputs were -4, then -3, then -2, then -1. That's also increasing by 1, isn't it? If you were on a number line, right? Because here's your 0. If you were down here at -4 and you moved to -3, you've increased by 1. Then you move to -2, you've increased by 1. Then you move to -1, you've increased by 1. So even though we subtracted 3 and added 4, the outputs both increase by 1 every time. And we call this an additive relationship. Okay? So if you see those words in a problem, you need to know what they mean. That's an additive relationship. So let's talk about figuring out which possible ordered pairs would work for a function rule. Okay? This is going to be example 3. So if I give you the equation, because remember a function rule is just simply a math equation or a math formula. What's a math formula that you've memorized in the past?
BH. Volume equals base times height.
Okay, that's simply a function rule, basically, right? There's input and output. If I give you this equation, y equals -x plus 5, and then I give you these different ordered pairs, -2, 3, 1, 4, -3, 8, and 2, 7. How are we going to figure out which ones of these would work in this equation? Well, here's what we're going to do. We're going to write our function rule, negative input plus 5. What's the input for this first ordered pair?
-2.
So let's put -2 here, and then let's work this to see what we get for the output. -2 becomes +2. +2 and +5 make +7. Did that give 3 as an output? No. Okay. Let's try it with an input of 1. If I put +1 here, -1 and +5 will make +4. Does this show an output of +4? Yes. So that ordered pair satisfies this function rule. It works in this function rule. Now let's change our input to -3. -3 makes +3 plus 5. +8. Same sign, add and keep. Do we have 8 as our output? Yes, we do. So that one works as well. Let's try the last. Oh, I didn't mean to erase that negative sign. Let's put that back up there. Let's try the last input of 2. If I get -2 plus 5, that's going to give me +3. Does that work? No, because that said 7 would be the output. So I've determined that out of these 4 ordered pairs I was given, these 2 work with this function rule, with this equation. But the other 2 do not work, okay? So I'm able to determine which ones could be a possible solution. So skill check A on the next page lets you practice working with ordered pairs and function rules, taking some input values and finding what the output would be and making a set of ordered pairs, and then determining whether the ordered pairs you're given work for that function rule or not. Okay?